Hey everyone, and welcome to The Explainer. Today we are blasting off on an epic tour of our cosmic neighborhood, the solar system. We're going to use your grade 8 science booklet as our map, breaking down everything from the fiery heart of our system all the way out to its chilliest icy edges.
All right, let's just jump right in with a number that is, well, it's pretty much impossible to wrap your head around. 15 million degrees Celsius. And that mind-blowing temperature, it's not even on the surface. The surface is a cool 5,500 degrees in comparison. Nope, this insane heat is happening right at the very core of the sun, the star that's holding our entire solar system together with its massive gravity.
So, how in the world does it get that hot? Well, it's all thanks to this incredible process called nuclear fusion. You see, deep inside the sun's core, the pressure is just immense. It's so intense that it literally squishes hydrogen atoms together to form helium. And that one reaction, it unleashes a truly colossal amount of energy, the very same energy that lights up our days and makes life on Earth possible.
Okay, so here's our itinerary for the tour. We're going to start at the heart of the system, check out the rocky planets, then the gas giants, see what's in the debris fields, and finally, bring it all home to talk about Earth. All right, first stop, the heart of the system. You really can't overstate how dominant the sun is. It's this colossal ball of hot gas, right? But it's so massive, it makes up 98% of all the mass in the entire solar system. Seriously, everything else, planets, asteroids, you name it, is basically just cosmic dust in comparison. Okay, let's start our planetary tour. We're heading into the inner solar system to visit the 4 worlds closest to the sun. These are what we call the terrestrial or rocky planets.
Now, before we meet them, it's super important to get this. There are 2 main types of planets. You've got your terrestrial planets. They're small, solid, and rocky. Then you've got the gas giants. They're huge. They're not solid at all, and they're way out there. Think about it. When the solar system was forming, the heavy, rocky stuff could handle the heat close to the sun. But all the lighter gases, they got pushed way out to the colder parts where they clumped together to form these massive worlds. Keep this difference in mind, because it explains a lot.
So first planet on our list is Mercury. This place is all about extremes. It's so small that its gravity can't hold on to a real atmosphere. What does that mean? It means the most insane temperature swings you can imagine. We're talking hot enough to melt lead during the day, and then it plunges into a deep, deep freeze at night. All right, next is Venus. People call it Earth's sister planet because they're about the same size, but honestly, it's more like our evil twin. Its atmosphere is so thick and toxic, it's created this runaway greenhouse effect. Get this, it's actually hotter than Mercury, even though it's further from the sun. Oh, and just to be weird, it spins backwards. Yeah, Venus is a lot. And here we are, Earth. We're going to come back to our home planet later, don't worry. For now, just lock in its location, 3rd rock from the sun. That distance, by the way, about 150 million kilometers, is super useful. In fact, astronomers use it as a standard measurement. They call it 1 astronomical unit, or AU. Okay, last stop in the inner solar system, Mars, the red planet. Today, it's pretty much a dry, cold desert, but when you look at it, you see things that feel kind of familiar. It's got volcanoes, it's got polar ice caps, and it has this absolutely gigantic canyon system called Valles Marineris. This thing makes our Grand Canyon look like a tiny crack. All right, buckle up. We are now crossing the asteroid belt to go visit the absolute titans of our solar system. These next 4 planets are the gas giants. They're mostly made of the same stuff as the sun, hydrogen and helium, but they just never got big enough to ignite that nuclear fusion at their core. And the first giant we meet is the undisputed king, Jupiter. This planet is just massive. You could take all the other planets in our solar system, every single one, and they would all fit inside Jupiter. And that famous Great Red Spot, that's not just a spot, it's a storm, a hurricane bigger than our entire planet, and it's been raging for at least 300 years. Just incredible. Next up, we've got Saturn, the planet famous for those absolutely spectacular rings. Sure, other gas giants have rings, but come on, nothing compares to these. They're this huge, shimmering disk made of ice and rock. And here's the wild part. They stretch for hundreds of thousands of kilometers, but they're only about 10 meters thick. That's like the height of a house. Unbelievable. Okay, this leads to a really cool trivia question for you. Think about water's density.
Now, looking at all the planets we visited, which one do you think is so light for its size that it would actually float? Any ideas?
Yep, you guessed it, it's Saturn. Because it's mostly just gas, its average density is actually less than water. So if you could somehow find a bathtub big enough to hold it, the ringed planet would literally float. That has to be one of the coolest facts about our solar system, right?
Moving further out, we get to Uranus. Now, this one's a little different. It's often called an ice giant. That's because it's got a lot more icy materials, things like water, ammonia, and methane, compared to Jupiter and Saturn. And a cool piece of history for you. Uranus was the very first planet ever discovered using a telescope. And our last stop on the planet tour is the stunning deep blue world of Neptune. So where does that amazing color come from? It's methane gas in its atmosphere, which absorbs red light and reflects back that brilliant blue. And here's another extreme for you. Neptune is the windiest planet. We're talking winds that are faster than the speed of sound. Wild. So we've seen all the planets, but they're not alone out there. Not by a long shot. The solar system is also filled with these huge areas of, well, smaller stuff. Think of it as the leftover building blocks from way back when the planets were first forming. And this kind of breaks down those main zones for us. You've got the asteroid belt, that's all the rocky stuff between Mars and Jupiter. Then, way out past Neptune, there's the Kuiper belt. It's a huge region of icy bodies, and it's where we find dwarf planets like Pluto. And if you go even further out, you get to the Oort cloud, which is where we think comets come from, starting their long, slow journey towards the sun. Okay, what a trip. But after all that, it's time to come home. Let's zoom back in on Earth and really figure out what makes our planet so special. Why is this the only place, as far as we know, that has life? Really, it all comes down to one thing. Location, location, location. I mean, look at this. Our spot in the solar system is just perfect. Venus is way too hot. Mars, our other neighbor, is too cold. But Earth, we're in what scientists call the habitable zone. Not too hot, not too cold. It's just right. And being in this just right spot gives Earth an average temperature of about 15 degrees Celsius. And why is that the magic number? Because it lets water exist as a liquid. And liquid water is the key ingredient for life as we know it. So that leaves us with a pretty big question to think about, doesn't it? If this is the recipe for life, how many other Goldilocks planets could be out there, orbiting all those other stars in the universe? And that's our grand tour. Thanks so much for coming along. The universe is just an unbelievably huge and amazing place, so never stop asking questions and keep exploring. Hey, if you found this explainer helpful, do us a favor, share, like, and subscribe. And you absolutely have to go follow Mr. Chi on Instagram, TikTok, Facebook, and YouTube for more awesome stuff. We'll see you next time.